vacation. That was from like 2005 up to 2011, where I worked over here at Lake Elmo, or with Gatus at that point. And then the boys took over and hung out with them for a little while and got them going. Prior to that was 23 years with Northwest, our hometown airline.
Yeah.
I'm sure I made all of you really happy somewhere along the line. How many have lost your luggage? Yeah. So you know how that works. But that was a long, illustrious career, and I started in the 747 check hangar back in September of '82, and spent a couple of years in the check hangar with some very old antique people, even older than us, World War II veterans. In fact, I found out later on that one of the guys on my crew that I was working with was on the Indianapolis and survived. And if you're familiar with that story, it's stunning. But anyway, I was always told, don't go up behind Duke and spook him. And I found out later on why. But these are the kind of people I started with, which unfortunately a lot of people today won't have that ability. So 23 years with Northwest and a couple of years in the hangar, and then I went all the way on the ramp. So most of my career was on second shift of the last couple of years, working the ramp outside all weather, trying to take a tire off with a 4-foot torque wrench, torquing the bolt off because it was so cold and the grease is so thick. So it gives a whole different appreciation working in the winter outside. But we turned a lot of metal, moved a lot of metal, and kept you guys going on vacation. That was the important part. And some really good people in that group too. So anyways, got back on with Delta in 2011, got in the inspection department. Basically because of my experience in the past and also being an IA. I got my A&P licenses back in, I think it's 1976. So I've been doing this almost consistently since then, and even before then, I worked during the summer months at the University of Illinois. First job was painting airplanes. That was an exciting experience. And then worked on GA airplanes on and off through college too. So I've been actively involved in maintaining aircraft since basically 1976 at minimum. Yeah. Got an IA back in 1985, and that really parlayed me into being able to do a lot of additional work on the side. Worked for the FBO. When this original FBO was built, if you remember, with Bob Tweed, and I was his first mechanic over there. Even worked for Ed Mayer for a little bit. I'm sure people are familiar with him. That was an interesting operation. EAA member since 1972. Does anybody have a 5-digit EAA number? Oh, we are the rare ones. so we might actually make it to the top, maybe 10, 15 people, huh? So yeah, so there aren't too many of those of us around. So I've been attending EAA since, I think 1971 might have been the first time that we passed through there and stopped in. And the first time I camped was probably 1972, when all we had back then was a snow fence separating your campground to the warbirds, if you remember. Yeah. And we used to set our tent right there, and P-51s right in front of us. It was really cool. So I've been attending EAA ever since then. I've probably missed maybe 6 or 7 over the years. Sometimes just went over for a day, if I had a day off, whatever. And scheduled to go again this year too for a week and putz around. I also do a lot of tech support for the Piper and Cessna owners group. I've been doing that over the last number of years. And also for doing a little bit of backup with Steve Ells on the Cessna Flyer group, if any of you are familiar with any of the online forums. And I'll start off with just a quickie story. I was cracking myself up coming out of the house today. I just checked my email, and on the Piper forum, everybody's familiar with the Piper Seneca twin engine. Well, there's a thread going on. His alternators drop offline at idle. All right. Well, a lot of older generators do that too. We're not unfamiliar with that problem, but if your engine idle is low enough, you're gonna lose an alternator. So anyway, some of the threads I don't tackle all of them. I let what I call the forum trolls I just kind of watch them and just kind of let them do their thing. There's several on each site They're the regulars, they know everything, but they're not mechanics. I don't tell them how to fly, don't tell me how to wrench. Right, fair enough. So I'm watching the thread and they're just totally confused. But I'm gonna throw a little spark into this flame. I went online, I got a very large selection of manuals, and found the, on the Continental IO360, TS IO360s, I found the ratios for all the drives on the back of the engine. So I put that on there. It says, I'm gonna let everybody else on the forum figure out what their own ratio is for their own airplane based on the RPM. Here's the chart. So I looked at my phone and I'm like, oh my God. It was just lighting up, because now everybody's calculating how fast their RPM is on idle and how fast my alternator is turning. Oh yeah, I should be getting some more power out of that alternator. Oh, I'm a little on the low side. Well, what if it doesn't come on at this point? so I turned the trolls on. They're gonna be really busy tonight. There's some people that shouldn't own airplanes, and there's a lot of people that shouldn't work on them. And the nice thing with the group here is I know probably everybody here is pretty mechanical, which really, really helps, because what I've seen is not that consistent out in the real world. And I'm sure this group is, I haven't built an airplane. I've restored and put together enough of them. I could build them, and I've rebuilt enough of them to consider those as a rebuild. In fact, the only reason I didn't get a DAR rating is because the FAA guy said, well, you know, you really haven't built an airplane. Like, really? I've taken wrecks, and there's a lot of mechanics that have done even more than me. You know, when you take a wreck and put an airplane back together, that's building an airplane. But by the FAA parlance, that didn't quite qualify. So anyway.
Just gotta add a 0 to the end of the tail code. There you go.
Yeah, I wish. But anyway, that's a little bit of my background. What I'd like to do here tonight is give you a little insight on non-destructive testing, which actually the reason all of us are able to fly anywhere on any given any day, any vacation, or any airplane is probably because we have NDT. When I worked the line, I rarely ever saw an inspector, especially at Northwest. We did stuff, we just made the airplane get fixed, and it went away. Now in the hangar environment is a little different, especially in the Delta parlance right now, where I come from. So I use that as my baseline, because that's where I've really gotten all my training for all the NDT. In Minneapolis here, all of us inspectors are qualified in multiple disciplines, including borescope, which we do a lot of, unfortunately, FPI and MPI. You've all seen like the die check kits, perhaps, okay? We still use that. That's used quite a lot, and I'm gonna show you some pictures of that and how it's applied in the airline world. We do eddy current. Some of you may be familiar with that, because we have some ADs out on Piper aircraft that require an eddy current inspection on the bolt holes on the wing spars. Obviously because we lost the arrow down in Florida where the wing came off, killed a couple people. And the FAA said, well, maybe we ought to look at those a little more closely. Also, the other discipline, we do radiology. We have people that are qualified. I call it radar, but basically it's X-ray. We actually have X-ray people at the Delta site too. We don't do a lot of that. They used to do a lot more on some of the older airplanes. Just take snapshot of pressure bulkheads in particular. And then ultrasound and composite testing. Ultrasound is used a lot in composites. So basically, you know, the kind of airplanes that we're all dealing with are either going to be aluminum, or some of them are fiberglass. Probably not that much composite. Anybody building something with like as a composite, like an epoxy, pre-preg, much like a Cirrus? For me, even the regular, like the very easies and the Vigans, and those are all more like fiberglass layup, if I'm not correct, right? On most of the ones, yeah. But the principles still apply, and there's some really unique inspection procedures for those kind of aircraft. And a good example would be on the new Airbus 350s. Those are all composite airplanes. If you looked at a normal airplane, uses regular stringers, right? Aluminum stringers. We rivet the skin to the stringers. No, first time you walk in that airplane when it's a little bit empty, you know, everything is glued. It looks like something your bathtub is made out of. So there's no wires. It's all Cat 5 in the overhead. It's a whole different method of construction. Well, that also gives a whole different method of damage assessment, if you think about it. One of the things I've learned, especially working with my airline career, is the amount of damage that happens from ground personnel. Now, we don't always hire the most talented drivers in the world. And they have a tendency to use trucks and belt loaders as a slicing device. And if you saw some of the pictures of the damage, it's millions and millions of dollars of damage to aircraft. One of the last ones before I retired, the food truck, I don't know how they did it, but they got the railings on the food truck. They ran that truck into the back of the airplane, and it took two knife blades and went whack! Had two big monster ass slots in it.
Well, that's one way to solve the airline food conundrum.
It's just incredible. And so the airplane's down for weeks and weeks and weeks. So, yeah. But do the same thing to a composite airplane, all right? I mean, we've all had like a boat or something made out of a fiberglass. You whack it, right? You see any damage on the outside? No. What do you see on the inside? And you can see the whole inside. Right, you see it all blown apart on the inside. So there's new technology out, ultrasonic technology, that they don't necessarily need an inspector, but a mechanic can use, and it's actually an ultrasonic roller. And they can roll it on the skin and paint a picture, basically a picture of the damage underneath the outside of the skin. So technology is kind of keeping up with methodology, or vice versa, of the caliber of the airplanes that we're building. But they all have some unique issues. I said you can always have somebody who hit an airplane and not tell anybody. That's never happened, right? So anyway, what I want to do, well, I've got it broken down. I've got an overview. I don't know how long you guys want to stay here, and actually, if you have any questions anytime, just raise your hand and yell at me. My left ear is a little bit on the plugging up side there, probably from turbine noise over my lifetime. And we'll start with just kind of an overview. Does anybody know a history of NDT? Does anybody know kind of where it started? Any ideas? You gotta go way back, way back. Okay, not that far back. Basically, the history of NDT kind of started off with the railroads. Well, back in the early years, we had some pretty lousy metallurgy, didn't we? So what was happening to the wheels? Yeah, breaking wheels. So they actually developed the fluorescent penetrant and regular penetrant inspections were kind of derived from the methods they used to inspect wheels on rail cars. Kind of interesting. And then the next step, what we call a logical step, the technological step was X-ray. And of course, in World War II, between the mag particle, which we use on crankshafts, right, and metal parts, and X-ray, that really was the foundation for the development of modern day NDT. Stuff that we all kind of take for granted, but you don't realize that when you're flying on an airplane or even even a rail car, they still do that stuff on rail cars. So it's used in many, many different technological fields. Which, by the way, if you have any kids that are looking for a career field, NDT is really, really nice. The best part about being an inspector, you think I got dirty? You're gonna pull the airplane apart. You're gonna clean it, and then you're gonna go ding. I need an inspector. That's me. I come on out with my inspection equipment and look at it. Then you get to put it all back together. So it's a good career field for anybody who's looking for a change of pace, or your kids are looking for something to do. And it's well paying, and you can do it in multiple fields. Food service, nuclear fields, nuclear energy. Somebody's got to inspect all the welds. The Navy, oh my God, I'm diversing a little bit, but the Navy is looking for inspection personnel. They pay very, very well, okay, if you don't mind working on submarines. Because somebody has to inspect all those welds on that submarine to keep it intact so it doesn't end up like the Titanic.
Or the other one.
So anyway, I've got just kind of a quickie overview. See how this works for us here. basically your 5 W's, and you can apply this to whatever aircraft or project you're working on, as to who, what, when, where, and why. What are you trying to accomplish? Sometimes the manufacturers will specify a procedure or something that needs to be looked at on something you're building, all right? They may send out a service bulletin, a service information, a newsletter saying they're having a problem with a component, bracket, and they'll probably specify how they want it inspected. Now, most of us are not going to have access to the eddy current and ultrasound equipment, but the couple of items we do have are, obviously, one is a magnifying glass, and we all have access to those, your routine 10 power, trying to find a crack or a defect. The fluorescent penetrant, the quick spot check kits, right? And I'll get into that a little bit later because there's 2 different styles of that, and then we need to be aware of the capabilities and also the problems that you can run into using one or the other. So manufacturers will specify some of this information. Home belts, other than the kit manufacturers, right? Visual and penetrance, most likely that we're all going to run into here, right? Or borescope. I should have put that on here too. We use a lot more into the transport aircraft, obviously. Fabric actually kind of falls into an NDT world too. We all understand on a fabric airplane, you're supposed to test the fabric, right? Well, I have a maul and a sable. Maul doesn't do any damage to the fabric. The sable actually punches a hole. Technically, if you read the FARs, you are supposed to do what? You're supposed to take a sample of that fabric and have it pull tested, right? So that's actually kind of destructive testing. So it's a little bit, there's that gray area where a mechanic or an IA kind of looks at it and goes, well, let me just use my mull tester on it. If it doesn't go through it, you're probably fine. Okay? So I'm gonna apply non-destructive testing in hopes that you're okay. So go from there. And then obviously, experimental light sport and light sport aircraft have some very different requirements. Light sport aircraft are ATSM qualified. If they say you have to do something, you have to do it. They are the owner of the aircraft all the way around. Let's see. Next. Oh, I don't want to talk anymore. Nope. Nope. Here. Regular techniques, we were just talking about ultrasonic testing, mag particle, generally used on ferrous materials like your crankshaft, camshafts, all right, anything metal, bolts, all right, certain bolts on aircraft are life limited, need to be ultrasonic or mag particle tested, all right. A good example would be on Beechcraft products. You got some big bolts to hold the wing on, right? Ideally, they should be changed out, I think it's like every 5,000 hours. Nobody ever does that. But if you're going to rebuild an airplane and use the same bolts, it might be worthwhile having you take them up to Bulldog and have them throw them in the mag particle machine and see if they're cracked. Microwave millimeter wave testing, this is kind of unusual. We don't really see that at all. Radiographic would be X-ray, right? Penetrant testing, acoustic emission testing. Well, that's kind of neat. And thermography. Acoustic emission is dropping a part in water and then running ultrasonic waves through it. So that's a little specified technology that we wouldn't normally accomplish here, but it can be done. Thermography is also something would be an interesting experiment on your composite aircraft. We do this, thermography is using, you always see the advertisements for people coming out to do the IR of your house, right, to find out what's hot and cold. And actually, I've got a component, I'm going to show you how that works. Well, we do the same thing on control surfaces. So the shop might repair, we have an elevator on a 330 that's about as wide as this room and weighs only about 120 pounds. So the two of us pick it up, we take it down to the shop after they've repaired it, and we put it in the oven. We heat it up. So what we're looking for is we take it out, we take our little IR gun, and we go along there, and if it has water, what do you think it's going to look like? You're going to get a spot on your screen because the surrounding is one temperature, and the spot that has water in it has another temperature. So you can actually see if there's actually pinhole leaks in the honeycomb structure on the elevator. So that sounds like a kind of a little magical way to look at something, but you can tap test it, because like a lot of the composite stuff, you can have small damage to it, have water ingress in it, you'll never see it. And on a control surface, having water in a control surface is going to do what? Yeah, little balance and flutter problems. So that's one of the reasons that stuff gets checked like that.
How much water can an elevator for an A330 take on? It's gonna double its weight easily.
Probably enough where it could probably take a lot. I've never seen one have a lot of water in it, but if you consider the fact that on all the modern aircraft now we're running 3,000 PSI hydraulics, right? Those power control units, PCUs, have a lot of authority. So it would take a lot of mass, right? Probably a gallon somehow in the trailing edge. If you've got that much in there, you've probably got some big damage you're gonna see. Because the honeycomb structure is like a regular honeycomb that you see on a bee's nest. And that's exactly what the honeycomb looks like inside, beneath the skins on all the composite components. So that would take a big one. Actually, I've got a picture, I think it's a 757, that's got a really big D-lam in flight, which is kind of cool. So the next time you're flying, you're looking out the window and go, oh man, I've seen one of those before. That's not good.
Hey Carl, have you ever done any inspections on composite rotor blades? Well, that's a topic of discussion in the helicopter world.
Yeah, one is
No, but
That
it
didn't have
would be the
composite
same.
blades.
Yeah, it's composite is composite, so it'd be whatever the manufacturer would specify for damage limits. All right, and even on a rotor blade or a fan blade, and I'll show you some of the stuff we do on fan blades. Your manufacturer obviously is the Bible on what you have for limits and capability, and they're going to tell you how to do it. They may say do a tap test. We also have what's called a woodpecker. These are really technical terms for inspection personnel. But it's actually kind of a name brand testing component for composites. And basically, I've got a picture of it. It's a little handheld unit, and it's got a little pecker in it. It goes tick 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 tick, and you're going to go up and down on your composite components, and on your screen you'll be able to see the ones I've used at work. It's on the screen. It'll show it on the screen. So it's doing at a certain rate. I get a certain height on my signal, right? I go over a void, and it's going to sound different. Well, the handheld unit also picks that up too, and I got a big spike, right? So I can go around the damaged area or the delaminated area and find the same spot. So the same thing would be applied to anything that's composite, like on a rotor blade. Kind of the same thing.
For Rutan style, these Canard aircraft that are all fiberglass, part of the construction technique is after you've put the fiberglass on all the foam, it's called a quarter test. You go around the entire surface with a quarter and tap it, and you listen for delaminations.
Right, and I've got some quick reference sheets printed up for everybody. I think I got maybe 40 of them, so it might be enough here for everybody. Kind of covering all the components and items that I'm talking about and where to find some of these too, because I've got some in my backpack. I'll pass around here in a little bit. You can get a demo. It's basically a quarter, but it's a big coin, and they also make a tap hammer. I'm kind of getting ahead of myself on some of this stuff, because we're going to cover each one individually. But anyway, in any of the NDT stuff that we do, one of the biggest things is, remember, is our probability of detection, POD. What's the smallest item I can find? Whether it be ultrasonic, eddy current, visual, all right? If I don't wear glasses, looks fine to me. So sometimes you don't want the really sharp inspector, you want the blind one. Depends how much to look at. But also too, as I'm using some of the equipment that we have available, all right, the manufacturer is going to specify how much damage I'm allowed. you'd think you wouldn't allow any, but they may say you're allowed to have a small crack, all right, as long as it stays underneath my threshold. Anything above a line I put on there is rejectable and would have to be looked at again. So probability of detection is very important. In fact, one of the, we call it the rails, which are the like support structure all the way around an engine, and it looks like a rail just bent all the way around. We actually had a test from Pratt & Whitney because they were developing an inspection procedure, and they had a handful of us selected to go over and practice the procedure because they were trying to figure out, can we find the damage on the rail? And some, I did okay, thank you. But there were some other stuff, and it's sometimes it's hard to interpret. So it's not like everything can always be perfect, that you'll find something, you'll find something, and I'll miss it. We all do, and some of us are good at it, some are not so good, I guess. So probability of detection is important when the manufacturers develop any of the procedures that we're going to use, because they want us to find a defect. And they want to know, we have a 100% chance or an 80% chance of finding 10 items. In fact, there are like 15 items on the rail. And if you found like a large percentage of them, you're considered qualified. If you only found one or two, back to the office and have some more coffee. So that's one thing we have to keep in mind. Anytime we're doing anything that we're looking at, what's your chance I'm going to find a defect, right, if there's something there. Different methods again. I got a bunch of different, some of this is from Airbus, from some of the manuals that we had. Surprisingly, our manuals that we have, both Airbus and Boeing, had excellent articles and descriptions of some of the techniques that we use. Different procedures, standard practices manual. You can see NDT is all over the place when it comes to inspection groups. All right, so let's go into, since we're looking at the, let's do mag particle real quick here. Mag particle, non-destructive method for detection. Mag particle inspection is fast, easy to apply to the part. If you've ever, has anybody ever taken some of their parts up to a Bulldog to have the metal parts checked out for your engine? Okay, well that's what they do up there. MPI uses magnetic fields, and that's a couple of the procedures that we do. Both mag particle and eddy current are using magnetic fields, meaning that we have to have pretty much a magnetic component that we're working on, or a ferrous component. So MPI won't work on composites, won't work on plastic, glass, right? Different types of, it's got to be ferromagnetic materials, but you can do everything. You can do castings, forgings, weldments. If you can magnetize it, put a magnetic field in it, if there's a break in that magnetic field, you now have a north and a south pole, right? And that's kind of the premise on some of the inspection procedures that we use on a daily basis. Underwater inspection can be used, right? There you go. So if anybody's into diving, you can get into underwater NDT. I'll watch from upstairs. I'm not that crazy yet. I got some videos here too. Just kind of give a little idea. If you've never seen mag particle done, it's kind of interesting.
To generate a sufficient circular field, we use an artificial flaw detector. This flaw detector is called a pi gauge, or a segmented field indicator. This pi gauge is made up of 8 pieces of steel brazed together with copper. As the copper will not generate its own magnetic field, only the fields going through the steel will be shown. Therefore, on the back side of this, every copper line will show up as an artificial indication. To use an artificial flaw indicator, it must be directly connected to the part. For this, We merely put it on the part such that it sits on the part and makes a good contact. We will then apply the solution application to it and verify that we can see the artificial flaw lines.
What he's doing is using this
Having placed
component
the
to
artificial
gauge how
flow
much
indicator
current
on the
is
machine
sent through the
and on the
component.
part, we will now apply the suspension to it
Okay,
and apply the current to verify we do or do not have enough current in the part to generate a field. As we can see, none of the lines, we do not have sufficient current to generate a circular field. Selecting the original current or the initial current for the part, we used a setting of 2 on the dial, which gave us about 660 amps of DC current going through the part,
anybody get in the
which
garage?
was not sufficient to generate a circular field in the part so that the flaw detector showed the lines. Having increased the current going through the machine and through the part, we're now going to reapply the solution and apply the current. As you can see, the artificial flaw lines are clearly visible on the indicator, and this demonstrates that we have adequate current to generate a circular field through the part. After we remove the pi gauge from the part, we completely saturate the part with solution. As soon as the part is saturated and the solution is running evenly across the part, we divert the stream and hit the bar 2 times consecutively to apply the electrical current to the part. After hitting the bar twice, we now begin our evaluation of the part using our black light. As you can see on the part, anything that shows up as a very bright green and is typically linear would be an indication of an issue on the part. These routes show indications, linear indications through wear. According to our internal standards, this would no longer be acceptable for a service life in one of our products. We would reject this part and replace it. Upon completion of the evaluation of the part still has a residual magnetic field. This magnetic field must be removed prior to removing the part from the machine. To do this on the ADH2045, you merely push the demagnetizing button. It'll run through a demagnetizing cycle and remove the residual magnetization from the part. You always do this 2 times. At this point, there should be no residual magnetic field on the part. This can be checked later with a Gauss meter.
Has anybody ever had the compass go screwy in your airplane? To the point where you couldn't get it straightened out? I've seen that at work. And usually it happens around the cockpit, obviously, where the compass are. Now, we don't normally use a regular compass, but it's still a legal requirement, right? So if the flight crew writes up that the magnetic compass is 30 degrees off or totally out of kilter, the first thing you do is I have a little Gauss meter. You go out there and you start walking around. A Gauss meter is basically like a compass, right? And it'll swing based on a north or south pole. So it just lights up the airplane on the front end. Like, oh wow, that's got a problem. But good.
So does Prussian blue count as a form of NDT?
No, that's more of a contact. You trigger as a transfer. Prussian blue would be used for like determining how much contact if I have a flat surface, right? If I mill something, I want to make sure it's straight. Use a known straight edge. Put the Prussian blue on. Squeeze the 2 together, and you pull it apart, and you can see where the contact is or the knot is.
Ah, okay. I could have sworn that it was sometimes used, like with moving parts, to see what parts are potentially binding and which ones aren't.
You could use it like that, yeah. Like a bearing crush. Usually you use like a plastic. It's called plastic gauge. If you're putting a crankshaft and a bearing together,
Yeah.
and you squeeze that, and then you take it out and you measure it with a micrometer. Obviously, he's using it on a screw thread, but this is what it would look like with a regular crankshaft. And on crankshafts, you're actually going to do multiple shots. This ring magnetizer here actually makes the magnetic field go this way, and when he does the head shot, the magnetic field goes circular around the component. So when you're doing a crankshaft or a camshaft, you're actually going to do 2 shots on it, because you're looking for cracks going this way along the journals, and then you want to do another shot to look on the face of the counterweights, right? So it's not like you're just going to spray it. The solution that he's using is green, it's just dyed green, but it has extremely minuscule particles in it. And those will line up with the north and south poles that we've created with the magnetic field, right, if there's a crack. And this is a good example of a crack in a crankshaft right by the cheek. And that's what it would look like, right? So when you have a prop strike and you go, oh, I dialed the crankshaft out. In fact, I'm just working on, I'm just writing an article on a prop strike based on a photo and story a friend just told me it happened. This is why just dialing a crankshaft out is not always the safest thing. Continentals in particular have a tendency to dial out really, really nice, but crack later on, and you'll find out 100 hours later while you're in flight. Lycoming seem to be a little bit better. If you dial one out from a prop strike, you're probably going to be okay, but it's probably not real smart, right? But anyway, the people think that that's a good way to go sometimes. But here's doing a camshaft, gears, connecting rods. So you bring all your components, flange on the crankshaft, okay? So this is what they all look like when they go up and go into the engine shops. And this is actually stuff that you can do too. You can buy FPI kits. Generally the expensive part is the black light. And I managed to find one on Amazon a while back. It was the same ones we were using at work for a number of years till we went with a much bigger handheld unit. They use it for leak testing, for tracing leaks. You'll find if you do a Google search of leak trace kits, all right? Put a certain oil or dye in your oil on your engine, and then you can use a black light, and you'll find the leaks. Okay? They use them a lot, and apparently the automotive and trucking industry is really popular. The lights can be very expensive. I got a really good deal of mine because I think I paid $200 for it. Normally they're about $1,000. Yeah, so a good black light is kind of critical. And this is a little magnometer, all right, checking for trace magnetism. And then on a regular basis, the fluid needs to be checked for the amount of particulate that we use. Oh, yeah, here's, this is the DC-9 landing gear bolt. Now, I don't want to scare everybody from flying, all right? I got some pictures on here that are like, wow, I can't believe that was in the airplane that long.
It looks like it was a DC-9 landing.
It was, yes, and it came out of a Dash 50 down in Hangar 4, and it took 2 days to get that out. It's about this big around. It's easily the size of your arm, holding one of the ears in on the main landing gear. They pounded on that thing with anything they could find, and it finally came out, and it sounded like a shotgun went off as it popped out. Probably due to lack of lubrication over its lifetime. It's been in it for quite a while. Luckily, it never failed, but you can see the chrome is just gone, all right, from lack of grease.
The 50, how long ago would that have been?
Look at the date on my...
They're all gone now, aren't they? They're all...
Well, we got the 717s.
Yeah.
And those are kind of identical to the DC-9s in a lot of ways. There's a lot more electronic mods to them. But the basic airframe is kind of about the same.
I suppose once you get to a certain size range with planes, you can, as long as the frame is still good, you got enough room to be, okay, yeah. I'll take this part out, put in this stuff here.
Yeah, and we can still get parts for them. We parked an awful lot of we don't have them all in operation. So I think they're down in, God, I think they're in Arkansas. There's an airport down there that is kind of our airline junkyard for the DC-9s. And if we need components, they make a phone call, they send some guys down there to rob parts. So some stuff is kind of unobtainium, and it's got to be taken from a live airplane. That's why in some ways a lot of the aircraft are never taken off of the legal certificate for the airlines, but they park them because once you take it off certificate, now it's a used part from outside of your system, if you think about it. So if you keep them on your certificate, right, it's kind of a flying part. It's the airplane just kind of sitting there just waiting for me to grab some stuff off. But
The parts bleed.
Penetrant. Penetrant and the fluorescent are basically about the same, other than the fact that we're using black light, and this is the stuff that we can do on our airplanes here.
In a similar way, a special liquid spreads over the surface of the part needing to be tested. The liquid seeps into microscopic cracks, just like rainwater filling cracks in pavement.
So the key is,
After wiping the surface
the
clean,
defect
a
has to be
developer,
open to
either
the
a
air.
fine powder or liquid, is applied to draw the trapped liquid back to the surface, making hidden defects visible. This non-destructive method detects flaws early, preventing failures and keeping materials safe.
Obviously, that can be used on all kinds of components. I've never seen it used on composite, but there's no reason you can't use it. If you have a suspected crack on a composite surface, or you might have dinged it with another airplane, or you ran your tug into it, or the car, or the kids threw something at the airplane, and it looks like it's a little goofy, there's no reason you can't use the liquid penetrant to try to determine what the issue is. Now, most common stuff that we're ever going to see here will be the spot check. So you have a cleaner, the penetrant, all right? And in this case, these are usually the red, you'll see the red dye, then the developer, all right, and then just another cleaner again. So the developer, after you've let the dye sit on the part, then you clean it off, spray the white powder developer, which could be used on a lot of other items too. You could use that on oil leaks, all right? Spray the white powder on your developer, you let it sit, and if there's a crack, you'll find a nice red line. We saw the green line on the crankshaft. Well, you're gonna find a red line using the spot check, the spot developer. This stuff can all be, you can get it through, they call it metal check. Magnaflux is the other big manufacturer. You can get this stuff through Amazon and also on Aircraft Spruce, which I'm sure we all have accounts that we use on a regular basis. This is basically kind of covers the sequence: prep, application, remove the excess penetrant, put the developer on, inspect it. If there's nothing out there, then clean it again and make it go away. This is a system that I actually have. I have put together at home, and this is my light that I've got here, the OptiPro. If you're going to use this kind of a system, you can get little UV lights that run on a couple little pen cells. They probably won't have enough output. These put out like 1,700 lumens. They're pretty bright, not something you want to shine in your eye. So there are some limitations using this. You've got to make sure you have at least the right light to be able to find your defect if you're really looking for something important. This is an Airbus A320 main landing gear attach point up here. This is for the actuator, which is about this big and that big of a diameter of a piston. What happens when we take these out, we're doing gear changes, is we find corrosion on the bearing up here. So they take the bearing out, machine shop comes out with this really nice hydraulic, those guys are geniuses too. They come out with this little setup and they'll cut a brand new bore and cut the corrosion out. Well, when we cut the corrosion out, bing, gotta go out there and we have to inspect it. So we're doing exactly the same thing. We're gonna apply a spray penetrant, let it sit on there for like maybe 20 or 30 minutes, and put the development, clean it off, spray the developer on, and this is the black light that I'm using, and I'm looking to make sure that they've got all the corrosion and there's no other hidden damage in the bore. And this is what it looks like with spraying the penetrant on. It's the same green stuff, only that it comes in a can. And if it's good, we use a black light, and these are pretty healthy lights.
Channel, physical penetrant inspection or
I got about 30 minutes worth of videos. I don't know if you guys are interested in seeing them, fine. Because I don't want to keep you here till midnight, but I probably could just do that.
Typically, 3 products are used.
But basically, it's the same thing what I was just explaining.
Or even using a
And you can use this on weld. So if you're doing welding,
covers the inspection area.
you can do the same thing.
Most specifications require a minimum of 10-minute dwell time. The dwell time
She's kind of articulate.
is when the penetrant's doing its work.
Like the
it's
dynamic
getting into
speaker.
Yeah.
the
They picked the light.
Your 10-minute
They had a hard time finding
dwell
somebody to
time
go in front of a
for ready
camera.
for the penetrant removal step.
But we call it the dwell time. The dwell time is how long your penetrant sits on the
Of course, we
component.
want to leave penetrant that's in any discontinuities.
Yeah,
So this is a.
You're killing me, honey. Just killing me.
Yeah, she's very passionate.
Baked under black light at 350 degrees for 10 minutes or until neon green.
Oh. Alright, now she sprayed the white penetrant, or the white developer on it, alright? There it is. Alright, this is where the crack's gonna look like.
Visible on the wall, so what do we do now? That all depends on.
What do we do now?
What do you do now?
Throw it away.
Throw it away. Yeah, get another one.
This part may be accepted as is, it may be rejected.
And
it
again,
may be reworked.
probability of detection,
Keep in mind
alright?
that reworked
Able to find that one, if she said it may be accepted as is. They may say you're allowed to have a 1/4 inch
In
crack
most cases,
within
it will
a
be
couple of
most
inches, or maybe
fields
2 or 3 cracks
and
along
it's
that
to
weld,
remove the
right? As
residual
long as they're spaced far enough apart.
I mean, technically speaking, if they had a literal zero tolerance policy, then you wouldn't even be able to get it 5 feet out of the factory before it had to go back in for repairs.
Right, yep.
Oh, it got bumped by a 2
Yeah.
mile an hour gust of wind, gotta bring it back.
This was on a pit special that we did, right? And we had some suspect welds, and sure enough, this is what it looks like when we hit it with the spot check. There you go.
Uh-oh.
Right? Now, sometimes you can see this with a 10 power glass, or you might be able to see it with your eyes. But let's say the airplane had, I don't remember I think we were just changing the engine out. So for some reason we flagged this and we hit it with the spot check, and sure enough, we had cracks in the welds. Right? So if you ever put the airplane on the nose or a prop strike, anything that can get damaged needs to be looked at. Oh, it wasn't a big one. I only broke 6 inches of the blade off, right? Well, you know, there's people that justify that too.
Yeah, tell that to the crankshaft.
Yeah, tell it to the crankshaft, right? Tell it to the engine mount when you're flying a pit special and you're pulling, what, 4 or 5 Gs on a regular basis, and hope the engine stays on there.
Is that repairable or?
Yeah, sure, yeah. Ideally, you're not supposed to re-weld welds, so a correct repair technically would be to grind that component off, grind the weld off, and then re-weld the whole section. Something like that, I think we might have taken it off. I don't remember if we did it in the shop here or we sent that down to aerospace. Sometimes you're better off letting a professional do the ones that are really critical as far as safety goes. The one thing I do want to point out though, I don't know if I have another. Oh, here's another one. This is a case crack on a Continental. And
Looks like there might be a little Continental on that case crack.
well, you're actually allowed to have case cracks on an engine, okay? And Continentals had, this is on a 470, but on the 520s, like on Barons and Bonanzas, they've had case cracking and that since I can remember back then, right? So they have the AD for checking it. They also have serviceable information saying where the cracks are allowed. And surprisingly, you're allowed to have, I think it's up to a 3-inch crack on the top of the case. And the best part is you can stop drill it. Really? Well, yeah, well, the first time you do one, you're like, yeah, okay. Stop doing, and you
So
fill it
they
with
already
epoxy.
leaking oil by then?
No, not necessarily, but usually it shows up because it is leaking, because it has oil inside on the backside. So that oil is acting exactly just like a developer intended, okay? It's leaching out. Everybody has oil leaks on their car, their engines, or airplane engines, trying to find it. Hopefully you don't have a crack, but sometimes that's where it's gonna manifest itself. It's like, wow, I didn't have that oil there before, and you look there, oh, wow. So it's actually possible to have cracks in the upper part of the engine, basically below the cylinder deck is a no-go. And I've had, if you're familiar with the Continentals, where the mags are on the front, right up in here on the 520s and the 470s, I've actually had cracks go from cylinder one, the base, all the way up to the base of the magneto, right? And then, of course, that's a little longer than 3 inches, so. And the first time you ever see the light case, which is where the problems are manifested, compare that to the heavy case, you're gonna go, oh, I don't think I ever wanted to fly behind a light case. There's hardly any webbing in it. It's almost like a hollow crankcase compared to the webbing and the extra beef they put into the later style cases. Yeah, and you can see how well these show up. So, now the other thing I would use this for too, let's say I needed to stop drill this. I need to know where the end of the crack is.
Yeah, you do.
Right? And there's a good reason for that, because if we don't hit it, it's gonna keep on going, right? Yeah. Luckily, they're right across here and it just stops. So as long as it's not going through the hole, so let it go. In fact, this case has, I think has 2 or 3 of these on the top of it, but they're not going anywhere. You just re-inspect them. At work, fan blades. We all seen in the paper, how many people have hit a bird? How many people have been in an airplane and hit a bird? Oh man, it's amazing what one big goose can do to a jet engine. As we know, ask Sully what happens when you land in the Hudson, right? So we get blade hits or blade nicks, and we'll do the same thing. We can do either an eddy current, or if the temperature is good outside, we'll go out and do an FPI. And so we can go out on the ramp with our little box of FPI kit and inspect the blades right there. And as long as they're within limits or no crack, sign it off. Away you go, back down to Tampa. Another airplane that has a regular requirement for an FPI inspection is the Beechcraft systems. The Beechcraft, the Baron and the Bonanza. This is the spar carry through. This is if you pull up the seats all the way down the bottom, you got these big huck bolts down here, but they've had cracks develop all the way along down in here. So it's a regular routine inspection. And you're supposed, I think every 500 hours you would do an FPI on those. Now, one drawback between you've seen the green system and you've seen the red system. Finally, the FAA's kind of come out with some guidelines. The reason being is the spot check system fills the crack, right? So once you've used the red dye, the spot check on a crack, if you have to use the fluorescent penetrant, the red dye is going to prevent the fluorescent penetrant from going into the crack. So it's just something to keep in mind depending upon what you're doing, what component you're looking at. Normally 9 times out of 10, the little red spot check stuff will work fine for you, because you're not going to take it in and have, nobody has the $5,000 worth of equipment to do the FPI on a 150. All right, so just keep that in mind. There are some benefits and drawbacks to each system if you're trying to use them together. This is a forward landing gear. Look at the corrosion on this puppy. Forward landing gear attached for an Airbus. And they take the bracket out, take the bearing out, and this is the bearing housing. You can see the corrosion in here too, right? Also the corrosion around the holes. The shop will come out, they're going to grind the crap out of it, get rid of the corrosion, and then we're gonna come in again with the FPI, spray it on there, let it sit, and check it and make sure they've got all the corrosion out of it and there's no cracks. Obviously screw threads, real popular, landing gear axles on many of the aircraft, the 330s in particular, get the FPIs. It's more like just inspection. Here's what you don't want to see on your Lycoming, right? Oops, I had an oil leak. I wonder where it was coming from.
Looks more like somebody spelled cranberry juice.
Yeah. Well, luckily, the cylinder stayed on long enough to be able to check that one, because it's not uncommon to kind of blow out that section down there, and then you got a real big issue.
World's first Lycoming 3-cylinder.
Yes. So those are those are two of the couple of the big ones that we use on a regular basis. Let me get into we do the. I don't want to. How late do you guys want to stick around? Are you okay so far?
9:15. I don't know, maybe about another 10 minutes or so.
Okay. Well, let's do some composite. Give you a good idea of some of the composite stuff that we would be doing. This is the inner fan cowl. Remember I told you it's all honeycomb, right? So once we've determined where the damage is, it gets cut out, and the shock comes out, they vacuum bag it, and put the repair on, suck it down, and make it a really nice tight repair. This is the thermo I was telling you about. Here's the IR camera, and you've got the elevator out, and they're actually taking shots of it, looking to see where there's any additional moisture content inside the elevator. All right, and Chuck is kind of marking different spots here that are showing up on the camera. All composite again. This is on a 220, one of my favorite airplanes. Because we're building a composite airplane, what happens on a lightning strike? Where's the grounding go? Ooh. So what they do is they actually build in grounding straps in many of the control surfaces. Now this is up at the top of the airplane, you can tell we're kind of on the high end. The lightning has a tendency to hit all the high points on an airplane, or the trailing edges. So, in Bombardier's, Airbus's wisdom, apparently their glue was a little bit on the light side, and the bonding straps were coming apart and just peeling off the surface.
Okay, so got a couple minutes. Gonna try and do another.
This guy does
do the demo.
We're talking about how
so
the damage shows up on this.
Here's your. I'm even gonna be nice. I'm gonna use a slightly rounded.
What he's gonna do?
Chunk of
he's gonna smash a
wood
hump
here to
here.
act as my bumper on my truck.
Pretend this is a skin.
And so here we go. We're gonna. And the big thing is listen to the noise as it comes in.
Like you hear it crack?
Yep, that's our laboratory truck hitting the airplane right now.
But would everybody agree at this point, looking at it, there has definitely been some damage here, right? Definitely. I mean, you can hear it snapping and cracking and banging and making all kinds of noise, right?
But notice when he took the pressure off, what did it do?
The truck away. Actually, that dished ever so slightly. But
yeah,
you can tell a little bit. But we've had a couple of these times. Actually, it's interesting. I'm kind of surprised we ended up with that much of a dent in it. I've had some times where we've done this, and look at that level right there. It's pretty much back to almost. There's been delam, but when you start looking at the
backside,
at the fiberglass in the backside, you can immediately see spots where it's delaminated because the material has changed color. In fact, all in all, it's actually not bad. The back layers obviously didn't get as much abuse as the front layers because there would be tons of separation in the center on the other side. You can see we've done a repair right here, and it's got all the different layers, all the different patches, a step repair to have carried out a repair there.
And my point is on this one is that, like I was saying on the 350, you can do visible damage, what looks like no damage to the outside of the airplane until you get on the backside. And you go,
so,
whoops.
And if you ever are working on or inspecting a composite airframe, back to me.
And this is the carbon fiber that we use in almost all the modern aircraft now in the aviation world.
think the same thing can technically happen with really, really hard pieces of steel too.
Right. And we were talking about the tap test.
So you're working in the hangar and suddenly
Oh.
something happens. Something runs into an
Something
airplane.
happens.
Well, what do you do?
I don't know how
You
that.
find out, has there been damage? As much as there doesn't look like anything there,
Good to go.
we really don't know because we don't know the level of
Right.
potential delamination of the materials that impact had. So what do? Okay, let's talk about the procedure, all
So he-
connected and they're all act
he's
as
kinda gotta
one.
do,
Then we're in an area now where there's delamination,
Tap
right?
test.
Oh, yeah, you can hear it.
Big change. So what we want to do once we've got an idea that maybe there's some delamination in here is we want to start to map it out. And so what we're going to do is we're going to get some sort of a document and we're going to lay out our part, right?
This is what we would do on
And
recurrent
then what we
training. When
want
I
to
go through
do
recurrent
is
training
we
every
want to
couple
go
years.
through that part section by section
And you gotta
and
tap
really
it all
get an
out.
idea as to
Mark
what
it.
the state is of each and every square millimeter of that piece of material. So I'm gonna go back and forth, listening for a change in pitch. Okay, so that whole edge there is pretty good. I'm gonna go across, come over a little bit more. Change in pitch there, okay? And so what I'm gonna start to do is I'm gonna start to lay
High
out
pitch is bad.
here, obviously
pitch
there's
is
some
bad.
area in here that's delaminated. And so,
You have to figure out what's the norm and what's the abnorm.
okay, it's solid again, but it's delaminated in here. Oh, it's solid. Delaminated, solid.
Very subtle.
Change in-
Very, very subtle.
Can you feel it? Does it look like a tweak?
So what I'm getting is I'm getting a bit of a line that's coming down
I
here,
suppose if you did enough,
and it's
yeah.
kind of going like
You
that.
probably could, if the void was big
So I'm
enough.
gonna go over here.
If you had ear problems, you couldn't do this.
Right, but you can tell now, this is strictly a audio-visual inspection. Now, we would normally use like an ultrasonic,
And so what I'm
detection
getting
equipment on this.
is something that
and
looks
actually
kind
map it out a lot
of
faster.
more like that. Draw it out is I can follow and find where those separations are by just carrying out the
And that's a
tap
test piece, all right? So I
Again, you don't
mean,
even need
if
something
you're trying to
special
teach
as
somebody how to do
the,
something,
hammer.
right? He's using a small one there too. But if you're good,
I can use
and
something
you're
as simple
careful,
as
this
a
is what
tuning
you
or a
can come up
linear
with
or a
on a
penny
test
washer to help me evaluate the condition of that piece of material. So that's the basics of listening for the potential of delamination in an area on a composite component.
yep, so this is the woodpecker I was telling you about.
Today, we would like to show you how the Mitsui Woodpecker WP632AM.
You've got the damaged areas, all right?
First, switch on the WP632AM by pressing this power button and place the hammerhead on top of it. Then, press this standard reference value button. Once the standard value is obtained, a numerical value will be displayed here at the top.
On a good spot.
It is better to try at different areas several times to obtain the most accurate value. We wish to evaluate. It can be moved in the vertical,
Makes sense how it
the
operates?
horizontal, or in diagonal directions. Make sure the hammerhead is in contact with the surface at all times. You can see here that each measured value is
This one's giving you
displayed
numerical
and
value,
an
the
LED
ones we have
lights
at
up.
work, I'm actually having on a display.
The green light means the comparison to the standard value is less than 8%, which is good. A yellow light means
There you
more
go.
than 8%, but less than 16%, which is within acceptable levels. A single or double red light.
So you can cover a lot of
is-
area. If you're checking on your fuselage, on your very big end or your Koji. Hammers, okay? And I've got some in here if anybody wants to try one. Coin tapper. See, they're pretty good size. So it's not like, you could probably get by with a a really heavy duty washer. I mean, you can make your own. As long as you're consistent in how you're doing your capping, and you can tell the difference between a void area and a solid area. Oh, this is on a 220. This is on a 220 stabilizer. This is the skin on the stabilizer. This is the aft spar, and we had delamination, so we actually cut out the damaged area. They're going to make a splice piece on here and then cover it with metal. But this is all composite. There's the filler. There's the metal plate going over the top. So you fix composite airplanes with metal.
Beefier than it was.
And here's how you put an elevator on a 330. Oh! Well, a little baggage cart got carried away on that one there. But you can see again, composite, right? So the shop will come out, do the same thing. Remove this area, lay it up, and bag it, just like you build an airplane.
Was that a bird, or was that a part of the cowling taken out?
That was part of the cowling, the reverser cowling that got whacked by a baggage cart. All right. I don't know if anybody remembers the Pipistrel that we had over here for rental. The term light sport, which is basically all the home builds that we got.
That was my airplane.
That was yours?
Yeah.
You're familiar with it then.
Oh, yeah.
Yep. But look at the composite damage from a little stiffer landing than normal.
Yep.
Yep. Now the nice thing is a lot of the stuff is visible, okay? But what if you had just that hard of enough landing, right? That it doesn't look like much. It's probably okay.
Some paint on it.
I've seen that happen. Yeah, unfortunately. Right?
Jim, didn't they change the design of the gear, the landing?
Yeah, they did.
Yeah.
Well, I'll tell you real quick. So they put a heavier gear on this because it was a tweener, and that was a mistake. Because the gear transferred the load into the belly.
Yeah.
And so they changed it back and made the gear lighter.
Yeah, that did a lot of damage. Here's what happened when you mate two airplanes together.
And you made them.
Yeah, one usually comes out worse than the other. But again, composite elevator, right? In some ways it works out good because aluminum would have transferred all that force into the rest of the stabilizer. Composite, it gives, just like cutting with a saw.
I would have thought the denting that aluminum could do would absorb some of the energy, but
Yeah.
I guess it depends on how soft or hard the structure.
Yep. Yeah, and as they cut out the damaged area on that. So those are your kind of composite items. Manuals, of course, if you got doing anything, always try to get the manual from the manufacturer that you're working on. There's a lot of, and even I'm guilty. I go into the Cessna and Piper manual sometime and I read something I thought I was doing right for 40 years. And I'm like, oh, I didn't know that was in there. so just because I've been doing it for a while doesn't mean I've been doing it right for a while. So I have the same problem everybody else does. Ultrasound is the other thing that would be used for composite testing too, right? I won't get into that much, but in general, this guy kind of gives it a little bit of an overview here.
And what we're hoping to see is that as the transducer passes over the hole, we get a mark on our screen over here. So let's see how that works. First, we tell the system that it's at 0 degrees.
Exact same thing.
If you know what you were using last time, you can use that last setting, and you can see we also have 45, 60, and 70. Now we simply hit enter. Use some contact fluid.
It needs,
this could be a simple
you can use grease,
gasoline,
oil,
but
water,
use something a little bit
anything
better.
to transmit from the
and if you've ever had an ultrasound in the hospital,
transducer,
it's this material
made
a
it
little
to
more
the
sterile.
substrate that you're working on.
This little
A lot of
bit
times we
less
use
so.
lubricate, white grease
Yeah.
works fine too.
do our screen. You see it says 1.963
So what's happening,
inches. It's measuring the
he's
depth.
shooting
This
beams all the way
index
down to
finger
the
here,
bottom of that
my
block,
index finger
and as he
is-
goes across that
this is the
hole,
zero.
right,
Right
that
now
block
I'm
may
a
be
little
2
thick. I
inches,
got the gain
that
set
hole's
up,
at 1 inch,
but I want
so he's
you
gonna
to
get
see it.
different,
Now watch what happens. I'm gonna pass
measurements.
over this large hole. Watch carefully in here on the screen as I do it. I'm gonna start to move it over, nice and slow, keeping my fluid contact good. And let me
he hits the hole, it should jump up.
get it to go here.
Whoa.
There it is. Look at that.
See a spike?
You see that spike in the middle at about 0.75 inches?
And what that is, just like a radar gun,
discrepancy
you know,
in the
they're
system.
shooting a
It's
radar
that
at you
subtle.
while you're
You gotta look
driving,
for
right?
it.
Gets the distance,
And what you're measuring
how fast
over
you're
here
going
is
based
the
on
top
time.
of the hole.
What we're doing here,
So
we're
let's go
shooting
to
the
this middle hole, it's a little
ultrasonic
farther
sounds
down.
down, and we're finding it doing exactly the same thing. The hole shows up as a
And
spike.
I'll get it. Just give me a minute. There it is.
There
And
we
now
go.
you can see that one's just about at 1 inch. And then we could go a little deeper on the third hole. Get the system, you gotta make sure you have really good contact.
And the nice thing is, we can tell where the hole is,
There it is.
how far down it
It's
is.
right at
So
1 inch.
if that block was buried on,
So
well, we
you're
do it on
seeing-
like wing
and you
plate.
notice that you're seeing some
Right?
backscatter,
We can
some
tell how
double
far
here. What's
down
going on
the
there?
defect is,
Well,
maybe a
what's happening
crack
is
or
this
a void.
transducer is very wide. This is a tiny hole, so it's actually picking up two different portions of the surface there. So what you're doing is indicating that something between the thickness is.
You're getting that a second, I don't see. Obviously, whenever we're doing anything, you need a reference standard, all right? So Airbus on the 220s, this is a reference standard, carbon fiber, different thicknesses. So we take our ultrasonic equipment and we can calibrate it to our reference standard. Everything is always done to a reference standard when it comes to eddy current and ultrasound. You can make your own if you have to, out of aluminum, as long as you know what the thickness is on something. And we got all kinds of paper. Rex is doing a fan blade here on an RB211 on one of the Hawaiian Air 330s. And these blades are hollow. They're about this long. They're hollow and they're basically glued together. And he's doing what's called a phased array, which is ultrasound kind of combined with a couple different probes. And it actually paints a picture of the inside of the blade to check it. It took, to do one engine takes almost 2 days with all the blades.
Material. What's the skins material on the blade?
This is the couplant. Okay, so this is it's a lubricant for
What's the blade, the skin
Material.
of the blade?
oh, titanium.
Okay.
Yeah,
Good stuff.
unobtainium. I'm sure we'll be able to get a lot of that from Russia now, right? They love us. But you can see, we clamp it down, and we have to go. You have to go over every, to set up a path or a procedure. Oh, you said, can you see if there's a delamination? Okay, so there you are sitting in your airplane flying to Hawaii, and you look out there and you go, is that supposed to have a big bubble there? This whole panel is delaminated, and the low pressure on top of the wing is pulling it up. And we've had, not just us, but other airlines too, on 57s and 67s in particular, because they're a little long in tooth, panels depart the airplane because they've delaminated enough, nobody saw it, and it just pulls it off the top of the airplane. Usually it's out in the wing areas.
Sometimes it is, sometimes it's just like, yeah, we'll deal with it later. Used to, it was that way with like the doors when I was working Delta Ramp Agent. Sorry, that's a story for another time, sorry.
Yeah. Let's go. This will show you, we talk about corrosion, DC-9 door sill areas. So if you have corrosion, I know what it looks like. You're gonna know what it looks like next time. Here's how reverser works on RB211. You don't want to get your hand stuck in there.
No.
Oh, yeah, we're gonna land in the Hudson. We just took a couple bird strikes. I got the propeller going out here.
You fool, you're going exactly where the geese want
Yeah,
you.
so we can motor back to the base, right? These get this is on a 330. This is on the right in the right wing. These get tested on a regular basis. So they'll power them up. They power either hydraulic or generator, either one, based on what you've lost. Let me get that. That's inside of a muffler with a borescope. That's one of my rejects. Here's how it gets stowed. There's actually a locking pin that locks that blade in the right spot so it doesn't go up in.
I wonder how that works.
Yeah, there's a locking pin on it.
What's it for?
What's that for? So if you lose a generator or something?
If you lost both engines and you're down to battery power,
Ram air turbine.
this will automatically ram air turbine, and all the Airbuses have them. Actually, the other airplanes have them too. That
Drive hydraulic?
it will drive some hydraulics and some battery stuff, some electrical stuff.
All I can think of is
When we test these, you can hear this all the way through the whole building. They are extremely loud. The sound doesn't do itself. But they're spinning like 3,000 RPM. Leading edges. You see how fast they drop down here, watch. There you go, on 320. Now you're in boat mode.
it goes down a lot faster than it goes up.
More corrosion that we look through. This is inside of an A350. If you guys have to go, I'm kind of stopping, just kind of showing some generic stuff here, because I won't get into the eddy current and the ultrasound. That'll probably take about another 20 minutes. But this is the whole front section. Instead of having avionic boxes like we always have, right? There's 3 servers in the front part of that airplane that run the airplane. Everything is done through the servers.
Carl, you might want to just take some questions.
Yeah, if anybody has questions.